Well, good morning, good afternoon, everyone, and welcome to today's Exploring by the Seat of Your Pants event. My name is Geographic, and I'll be your host for today. I am coming to you in a little different location. I am in Monaco today, and I'll maybe give you a view out my window in just a second so you can see what I see from my window. It's not just the Around the Americas team who's having the good ocean view today. I've got a kind of a decent view today, too. So we are connecting. We're going into the field with Around the Americas team. This expedition is a 14-month voyage It started in May 2025. It's circumnavigating North and South America aboard the 48-foot sailboat One Ocean. The mission is
Hello, everybody.
Hi, everyone. I think you can hear us. If you don't mind putting in the chat, if you could hear us, we'll continue on for Joe. He's been having a lot of trouble with his connection this morning. Okay, great. I think we are live here. All right. Hi, everybody. Thank you. We're the Around the Americas team. And today we've got myself, Jennifer Dalton.
I'm Tess Shornack.
I'm Mark Schrader. Hi.
And we actually have crew member Mike Beamer is available as well. He might be popped onto the screen here as well. But here we are in southern Chile. And when Joe is available, hi, Joe. Welcome back.
Hi, guys. You would think a connection in a Monaco hotel room would be pretty good, but it's not cooperating very well today.
We understand. It's okay.
But before we do, I do want to show you the view out my window here.
Oh my gosh.
The harbor here in Monaco. All these fancy boats.
Yeah, they look a little bigger than our boat. That's for sure.
You would think they'd have good internet connectivity, but anyways, I'll let you continue with the introduction. Let's catch up on what you've been up to.
Well, yeah, here we are. We're in southern Chile still, deep in the southern Chile fjords, actually. We've had a lot of wind events and some low pressure events, which we'll talk about what low pressure events are. So right now we are hidden away in Bahia Tilly. It's a little cove that we're pretty well protected from some of these wind events. And we actually had snow this morning. So that's where we are. But we've been here for a couple of days, and it's given us a little time to start thinking about our route planning. Planning through navigating through the fjords has been interesting. And we are now starting to look ahead at Galapagos, because that's our intended route in the next month here is to get up to the Galapagos. And so what we're going to share with you today is what we go through on a daily basis: route planning, how we navigate, and weather systems. So I don't know, Joe, if you're able to share our slides with us, with everyone. Okay, so if Joe, if you have the availability, present mode on that. And you can click right into our tracker if you want to, and it'll just show where we are. Oh, well, we can start there. How about
Should we start there?
If Joe can go into our tracker, that would be great. And we can just show you where we are. So really, everybody, from where we are right now, we have over 3,000 miles to go to get to the Galapagos Islands. And so what we have to do is we have to get back to Concon because we have an electronic piece we have to pick up for the boat. So that's a couple thousand miles away, about 1,500 miles away. And then from Concon, Chile, we have a couple of options. We can either hug the coastline to get to the Galapagos or go offshore. And so we have a lot of factors that we look at while doing that. And anyway, that's the Galapagos there. And you can expand out and maybe just show where we are now, way down south.
There you go.
There you go.
We're way down there somewhere.
Way down in there.
There it is. There it is. There's the little dot.
Yeah.
So some route planning to do.
Mm-hmm.
Some pretty important route planning.
So you can skip through the slides, and then Mark, you can just tell Joe.
Right. Now you can see snow on the mountains. No snow on the mountains yesterday, and today there's snow on the mountains. So we want to keep going north. Route planning is really important for us, but you can imagine 300 years ago, that's the Darwin that was doing survey work down here in the Beagle Channel and coincidentally in the Galapagos with Charles Darwin aboard. I think Darwin was 23 when he was in the Beagle Channel and 24 when they got to the Galapagos or something like that. The captain was only 26, so I'm an antique by that standard. Anyway, those ships had to do very careful route planning. They couldn't go to windward. They couldn't go very close to the wind. Certainly sailing boats can't go right into the wind. We can maybe 30 degrees off the wind and make nice progress. They could do 70 or 80 degrees off the wind. So route planning became very important, currents and prevailing wind. So that's what they were dealing with. Go ahead to the next one. So since for as long as people have been watching weather and ships have been sailing, they've mapped where the prevailing winds are. And that led to what the trading routes around the world were. So what you see here, we're way down at the bottom here in the westerlies. So the flow down here for storms and weather is coming from the west, comes in, smashes into the southern part of Chile, and then splits and goes up or down. Next slide. If you take advantage of these winds, you're going to get someplace. If you don't take advantage of them, I mean, many of you with a bicycle know that you can't, if you're pedaling right into a strong wind, that's difficult. You might have to zigzag back and forth to get anywhere. A sailboat is just like that. You have to zigzag back and forth. And if the wind is really strong, you don't make much headway. So ship captains and people on board all of these trading routes have been keeping track of the weather for a long time. These are the wind patterns in the Atlantic and the Pacific. Go ahead to the next. Wind strengths and patterns. For route planning, that became key. And right here, you can see that the currents are really driven by the wind. In the south, the current flows from west to east. You see it coming by Chile and going through the Drake Passage and then around in the Atlantic. When it hits Chile, it goes north. Part of it flows north and forms the Humboldt Current, more about that later, and does a big circle around the South Pacific. middle of that circle, there's not much wind and not much current. So again, if you're a ship, you want to take advantage of those currents. And this is a chart that's been developed over time. And the next one is no wind at all, you're stopped.
There it is.
The next one on the left are wind and currents combined. The darker colored means stronger wind, stronger currents. The lighter is neutral areas, and you get the idea of the flow down here. That flow is really important to us to figure out, because as all of this stuff hits the archipelago, southern Chile, it goes through all these channels. So we have to be careful that we're not trying to go against a 6-knot current, since we can only go 6 knots.
Yeah. So we are really lucky today on board that we have some really incredible instruments that help us better track these weather systems. And one of the instruments that we use pretty much daily is called Windy. So here you have on the right side the currents that Windy is showing us. The darker is stronger currents. And then on the left here, we have the wind. And on Windy, we can track how these systems are progressing and watch how they flow throughout the week, which is really important information. On the right, you can see the Humboldt current, which is one of the currents that we were actually fighting on our way down here. So oftentimes the current was pushing against us at about 2 knots, which really slowed us down. So things like wind and current are really important in our decision where we want to go, which route are we actually going to take. And then you can go to the next one. So here is going to be Windy on a more global picture, so we can kind of see the overview of how this wind is interacting throughout the entire globe. So this is really interesting to watch these patterns and how the wind flows. And this is actually throughout the week. And I believe that this is this week.
Yeah, this is real time.
Yeah.
We're seeing it in real time, and we can see it move and make our moves accordingly.
Yeah. It is interesting because here in the fjords, it hits the mountains, and often the wind acts differently, flows through here differently. So we have to also focus on what it looks like locally. But this gives us a great overview. And now we can also see the low pressure systems, which low pressure indicates bigger weather systems, and high pressure often indicates better weather. So on the next slide, we can see our barometer. And a barometer is something that we actually have on the wall over here. We track it constantly, and the rate of change of the barometer indicates the change of the weather. So if the barometer is going up, that indicates the weather is getting better. And if it's going down, the weather is likely going to get worse. So we keep a close eye on it, and it really helps us understand what we might be seeing here locally.
Okay, thank you. And next slide, please. So these are all things we use to track, our route. And so right now we also use electronic charts, but also paper charts in case we run into any kind of problem with the internet, as you can tell. So our electronic charts look like this, what you see here on the screen right now. On the left here, if you can see, it's 32,000 nautical miles to get to the Galapagos. That's what we have to conquer.
3,200.
I'm sorry, 3,200. And so, Joe, if you can go to the next slide, please. So really, we use the electronic charts on a daily basis. We take all the factors in. We look at the weather, we look at the barometer, and we kind of plot a course as we go. So this is just me plotting a course using the instrumentation called Navionics. And so it can show you the whole, right now, this is real time. This is us in the fjords in Chile, and there's a lot of navigating going on. It will show you hazards. It will show you the different inlets. It will show you possible bays to pull out in. And we navigate this ahead of time. We maybe have to look at timing. We look at a lot of different things. So anyway, this is just something that we use on a daily basis and plan it out. And for looking ahead at going to the Galapagos, we'll plan our route going up through the fjords, and then we have a couple of decisions to make. So Joe, if you could go to the next chart for me, please. on these decisions that we have to make is from Concon, do we go follow the coast route up after looking at all what Tess said about the Humboldt Current and looking at, currents and weather, or route option 2, do we go offshore and use some of the trade winds that Mark was talking about? So what we're kind of looking at, you guys, is we're going to ask for your opinion as well as to get you involved a little bit. We would love to hear from you. And if you look ahead, and everything is always weather dependent as well. We always have to wait and see what the weather is doing. But these are our 2 options. Love to hear from you. And we're going to follow up to online, right, Tess?
Yes, definitely. So if you want to follow along with what route we end up actually taking and with more information about weather and decisions, if you're interested in that, go check out all of our social medias, One Island, One Ocean. And then also, as you saw at the beginning of this classroom, we have an incredible website so you can actually track where we end up going. And that's oneislandoneocean.com. So as you maybe have an opinion on where we should go, you can send that to us and you'll see where we end up heading.
But the goal is to see Anna in Galapagos.
Right.
Yes, it is. So we are headed to the Galapagos, and that's what we're very happy that Anna is joining us today to teach us more about deep sea sharks, skates, and chimeras in the Galapagos archipelago. So thank you for joining us. We're super excited to have you with us today, Anna.
Hi, Anna. Thank you.
Hi. Thank you for inviting me. It's so nice to be here. So I will love to introduce a bit the topic in deep sea and the importance of the ecosystems that sustain different animals, not only sharks, chimeras, and skates, but everything that lives in the deep sea, because we know very little about it. So please let me know that you can hear me because I don't see you anymore. And if I should start sharing my presentation.
Yeah, I hear you loud and clear, Anna. And if you're ready, we can start.
Wonderful. And so let's go through this adventure together. I'm going to share my screen with you. All right. So what you're seeing here is a picture of one very memorable dive in the Galapagos Islands. And this little friend here is actually a sea lion. It's an endemic species of the Galapagos. That means it only lives and occurs in the Galapagos. And so I'm very, very jealous of this it's amazing friend because he gets to live in the Galapagos, and he's one of the kings in this area. And this lady over here, she's extremely friendly, and when I was working here and doing some transits in the Galapagos Islands, they will come and try to play with me and mess around with the team, and it's just so joyful. So I've always been obsessed with the ocean, and maybe some of you might identify with that. And so I am from Ecuador. The Galapagos are the islands of Ecuador. So people in the Galapagos are people that came from Ecuador. And so for me, having this amazing treasure of Ecuador, which is the Galapagos Islands, was a huge source of inspiration. So there was no other path for me to become a marine biologist. So I work in Galapagos, but also in the Caribbean, where I got to see so many corals and get to understand the value of this species that we have in the Eastern Tropical Pacific. But we know very little about this species in the deep sea. But actually, we know very little about any species in the deep sea. So let's have a look. So this planet that we call planet Earth is actually a big blue ball. And if you will be an alien that comes to this planet, you will likely land in the water because you will have 71% chance to arrive there. And if you arrive in the water, what is going to happen is that you will see just water around you. And if you want to find life, there will be not more logical step than explore the water. And if you start exploring the water, you will see that it goes deep and deep and deep. As the average depth of the ocean is 12,000 feet. Can you imagine that? 3,000 meters. And for that reason, 99% of the living space in the planet is in the ocean. So there is no other place in Earth that can have more life than the ocean. And most of this ocean is deep sea. It's a world of eternal twin light, full of wonders. And so I thought, in order to understand it better, we should call up a friend from over there, right? So what you're looking at here is my friend, the Dumbo octopus. This is one of my favorite creatures. It lives only in the deep sea. And this is a real animal. This is not AI. This is a real species. Extremely cute. And they can grow big, relatively big. And I'm going to tell you a little tale about this octopus. So there's this octopus here. He was born in an area of the planet where the deep sea has already been exploited. But his mother remembered a deep sea full of wonders, a deep sea full of coral reefs, healthy, without any intervention from humans. So he tells to little octopus about this amazing place. And she tells that about him, so he finds some curiosity and wonder. And when her mother gets old and eventually has to go, little Dumbo octopus goes in a search to find these amazing places that his mother talked about. So he goes, and suddenly he discovered there is a lot of damage already done in the deep sea, because there has been bottom trawling in many areas for many years, and it's been hard for him to find these amazing pristine ecosystems. He heard from some friends that there were areas of pristine coral reefs in the deep sea, which are called cold water corals, but he doesn't find them. But he keeps looking for it. Everywhere he goes, he tries to find it. It has been already destroyed by humans. But he learns about these practices and he feels sad, but very sad, because these corals are ancient organisms that form amazing ecosystems, and they grow very slow, and they live more than 100 years. They can live up to thousands of years. So they might never recover. He's very sad and frustrated. But then he remembers his mother, and he knows he's cute, but he's determined, intelligent, and brave. He got that from his mother. So he keeps going, he doesn't give up. And in his journey, he discovered amazing forms of life, like you can see here. Jellies, and other type of octopus, like this crystal octopus, this wise friend that tells him a bit about the way to go. And then he gets very scared by this anglerfish. However, the anglerfish that he observed was not that scary. It's actually a very tiny fish. So he keeps going and going. And finally, he arrives to an especially interesting place. It's called La Isla del Coco. And from here, he found that he just have to go a little bit south to find an amazing area where there is still coral reefs that are pristine. So there he goes. And he arrives here and he finds a wise ghost shark. This ghost shark that you can see here comes and tells him, yeah, you are coming to the right way, but watch out, there is a rough shark. So he goes away and he gets trapped by a huge current that takes him away. When he thought he was completely lost, he finally opened his eyes. And what he found, something he cannot believe. This is a giant coral reef in the deep sea of the Galapagos Islands. This is a real imagery from the Galapagos Islands, and this is a real place, although the story is a tale. This is a real dream that exists, and animals like this octopus live there, and those are some of the last places where they can actually find this state of pristinity. The Eastern Tropical Pacific Ecuador in the Galapagos Islands. And I would like to say he lived happy ever after, but that's still up to us. We should make sure we do what we can in order for these animals to be living in spaces like these coral reefs in the deep sea of the Galapagos. So today I'm going to talk about a few topics. the pristine deep sea, cold water coral reefs importance, and shortly about the discovery of sharks, rays, and chimeras, because this work we haven't yet published. So I'm going to share with you as much as I can, but I tell you there are things that I have to keep because we need to first publish this work. So there is the tropical Pacific corridor. What you're looking at here, and I'm going to use now my laser. Here is the Galapagos Islands. The marine corridor of the Eastern Tropical Pacific is an initiative that was created by Ecuador, Costa Rica, Panama, Colombia, and Costa Rica. Panama, Colombia, Ecuador, Costa Rica are the countries that decided to start with this initiative with intention to protect the species that are being threatened outside of the marine protected areas, like hammerhead sharks that are species that are in danger of extinction in most places, but they are abundant in this area. So this area is characterized by rich currents that bring nutrients and create an area in our ocean that has no place to be compared with. Their endemism, their biodiversity, their abundance is unique. And so these areas are protected, and the protection has increased recently. But the abundance of life here is due to, in huge portion, to the deep sea. The deep sea features that create an amazing ecosystem of seamounts where many species like the Dumbo octopus and many types of sharks can live. And also, the same seamount changes help animals like the hammerhead to migrate from Galapagos to the other islands in the Eastern Tropical Pacific. And the integrity of the Eastern Tropical Pacific might depend then on these pristine deep sea ecosystems. So, as I believe images talk more and are more powerful than words, here you can see a hammerhead shark at 300 meters depth. So these animals do visit the deep ocean. And effectively, one of the topics that I wanted to talk about briefly is the sharks and the new species that we have observed. So these sharks that you observe here is the first time that is being shown, apart from the images and videos that have already been shared live at the Schmidt Ocean Institute, who has the rights of all this imagery. This is a new species of road shark for the Galapagos Islands. And this is also a new species of Haricota, so a type of chimera in the Galapagos. It's not new species to science, but it's a species that has never been observed in the Galapagos before. And like that, we have more than 10 species. And so I'm leading this work with several colleagues, and I will love to talk more and show more about these images, but because of the importance of this study, I will have to wait before I can share and talk about more before this study is published. But there is so much in the deep sea that you will learn a lot more here in this presentation than what I have shown so far. So these animals, as you can see here, this coral can be hundreds of years old. And within the marine protected areas, they are protected from human impacts. However, they are sensitive to the elephant in the room, which is climate change. So that's one of the biggest problems in the Eastern Tropical Pacific, climate change. And climate change affects different areas of the world differently. In the Eastern Tropical Pacific, in the Galapagos, here in this area, the bigger problem is, one of the biggest problems is the deoxygenation of the ocean in the deep sea. That is because the expansion of areas with low oxygen that are called oxygen minimum zones. And I'm going to explain that to you briefly. So what is happening is that the first layers of the ocean are warming up. And with that, not only the upper layers warm, but there is a layering of the ocean, where the first layer of the ocean, the first layer of the water column is very hot, and that complicates this penetration of oxygen in the deeper waters. And with that, with less input of oxygen, the oxygen minimum zones that are already naturally extensive in the tropics start expanding. But then what? What happens when they expand is that the habitat that is available for these deep sea species is going to shrink, it's going to reduce. And if you are a coral that creates all this habitat for other species to live, species like the Dumbo octopus, like sharks, like fish, and anything that you can imagine, if they cannot move away, we might be losing this habitat that is essential for many organisms. And so we went to study what is happening with these oxygen minimum zones and the distribution of different corals in the Galapagos. On board the Smith Ocean Institute vessel Falcon 2, we explored the Galapagos, and here are some of the sites that we visit. And so in this specific research that I'm leading, the questions are, what is the distribution of corals in these zones of low oxygen, which coral species are living here, and what are the difference between islands? Because we didn't only go to Galapagos, but also to Isla del Coco, which belongs to Costa Rica. So we visit, these are the sites I'm focusing in, and using this robot, an underwater robot that can go thousands of meters below the sea surface, we went there and then we collect species and environmental data. And one thing that we never expect to find is this type of ecosystems in areas that were almost anoxic. What you're looking at is a coral garden in anoxia. And as you can see, you may say, what is that pink thing there? That is a brittle star, which is a family of sea stars. And they were covering all the seafloor for hundreds of meters. And this yellow coral was the dominant species and is a new species to science. So with the collection of these species and the analysis of the DNA and the analysis of the structure of the species and the quantification of the data that we found, our results indicate that, first of all, in the Galapagos Islands, we do not reach anoxia. That means we do not reach an area where the oxygen is almost zero. We have oxygen minimum zones, but not this anoxia. While in Isla del Coco, we did reach anoxia, conditions that are almost without any oxygen. And in that area, we still found life. Also, the extension of these areas with low concentration of oxygen in Galapagos were a lot shorter, while in Isla del Coco, they were massive. So coral reefs like this, live within these oxygen minimum zones in the Galapagos, but in the Galapagos, we do not reach anoxia. And in Isla del Coco, they live, particularly this species is the only one that formed these incredible ecosystems in anoxia. So the conclusion for this study is that despite anoxia in Isla del Coco, this extensive new species of coral form an amazing ecosystem for many other species. Also, we found that the area with this coral occur in Isla del Coco has some hills that actually the data demonstrated that are one of the factors that influence strongly the presence of these ecosystems, suggesting that hills and this type of high topography help the coral to survive. And we also observed low number of otter species in Costa Rica in comparison to anywhere else, especially within the anoxic areas. And in the Galapagos waters, we did not find this anoxia, and we did observe coral reefs in oxygen minimum zones. So the outcomes of this study is a very important baseline to understand and have awareness about the threats to these pristine ecosystems in the Galapagos. Also, we found this coral likely adapted to live in these conditions that we still have to explore. And finally, we have found about 10 new records of sharks, skates, and chimeras, and some of those are new species to science. So thank you so much, and this work that I have done was supported by National Geographic and Schmidt Ocean Institute, and National Geographic was very excited about the results, especially about the discovery of the yellow coral, that they include a section of that in one of their kids magazines, so maybe you can find it. I know there is versions in the UK and in New Zealand, so maybe some of you are there and you might find this. Will be awesome. And so finally, thank you to all the partners involved, all the international scientists that lead different components of this expedition. And especially thank you to Schmidt Ocean Institute for providing free of charge the vessel and the robot and all the equipment and the amazing team that helped us to actually get this science done. So thank you so much to all of you for listening. And remember that places like the Galapagos deep sea are a unique window to how the deep sea was before humans impacted it. And so it is a legacy for all of us. And it's our duty to make sure that we preserve these last pristine seas. Thank you so much.
All right. Let's get everybody back in here. I'm going to keep my camera off just in case. That'll help with the signal. Anna, thank you so much. Around the Americas team, thank you for your great presentation about your route to the Galapagos. And I do want to give a shout out to 4B in Charleston. They are in the chat right now, and they want you to know a few things. They want to share their best wishes with the crew, and they think that you should pick open ocean to the Galapagos because they don't want you to be stuck in the fjords for weeks and weeks. So head for the open ocean.
Yeah, love to.
I would like to also let them know that their buoy 171 is doing some pretty amazing stuff right now with some of the low pressure storms coming through. So please check out our tracker for the buoy number 171. It's out there off Cape Horn at the moment.
Well, spoiler alert. Did you just check it?
Spoiler alert. It may be around 4 meters of wave height that we're seeing, and it's not even done tracking yet. So we're seeing some big weather. Definitely go check it out, and you can watch the trends. It's really, really fun.
And Anna, thank you so much. I hope that we are able to connect with you when we're in the Galapagos, because I am completely in love with a Dumbo octopus now. It was the best story. And absolutely loved it. Thank you so much. That was
I'm so happy to hear that.
Yeah,
I'm so happy to hear that. Like, this is actually a discussion I had previously with my beloved National Geographic officer when I talked him about this topic that is not something very common. And so I mentioned, look, think about an octopus, and this is what's happening with something. But why don't you present that part? Like, well, because that's just a fairy tale that just make up. But like, yeah, but that's great. So I thought, because the audience that is visiting, that's watching this today, are amazing groups of young kids and young and teenagers. So I thought this might be appropriate for the audience. I hope I didn't make this too heavy. I hope it was understandable.
It was terrific. And thank you very much. It's really an honor to see what you're doing to help protect our oceans. And we love seeing what you're doing, and you're a true ocean steward. Thank you very, very much.
It was a real honor to make sure I can share what's happening with the world, because, as I said, it's our duty, is our legacy to make sure that we protect. In order to protect, we need to know, we need to love, we need to understand these areas. So I hope this helps a little bit, because if we all do that, so we are moving forward.
Absolutely. Well, let's get in on some Q&A action. If you are tuning in via the chat, don't be shy to send some questions in. I think anything's fair game today. Deep sea, Galapagos, sharks, maybe Dumbo octopus, navigation, sailing to the Galapagos. I think there's lots of things we could talk about today. So let's see what's on classroom minds. In fact, the first question I have here, let's grab this one from our 4B crew. They want to know, do the new species have names yet? And do you get to name them?
So it's an excellent question. So because we the methods we are using is an underwater robot, an ROV with a camera. All the information we have from this species is visual. So as I said, we have new records. Some of these species might be new species to science. However, in order to name a new species, we will have to collect it. We will have to count very fine structures, get a genetical sample, and only then we could name this as a formal new species. However, because of the extensive difficulty of studying the deep sea, and for species like sharks, like this rock shark, there is characteristics that we can already use, and the knowledge of its distribution elsewhere, that we can know, okay, this species is likely new to science, and knowing also what we already have and know from the Galapagos, we can certainly say this is a new record, so something that has never been observed in the Galapagos, but in order to name a new species, we'll have to collect it. So that will be a next step.
All right, very cool. Let's get some faces in here. We've got some great students backstage, so let's give them a chance to come in and ask some questions. Let's start with room 9 joining us in Maine. How are you doing, room 9?
Thank
There they are.
You see that? Are you okay, my friend? Go ahead.
What are the Dumbo octopus predators?
Oh,
The Dumbo octopus predator is an excellent question. You know what I think you should grow up and study that question. Because I think there is not much information about who are the predators of this species. So we know for many species in the deep sea, some whales eat squids, and that's the general information. But we don't know specifically who is eating Dumbo octopus. Probably everything that can see it, but specifically the number one predator, we don't know. But likely species like sharks, species like whales might eat this octopus. But yeah, that's an excellent question. I see we find a little scientist over there.
Say thank you.
All right. Do you have another one handy there? We can get another one before we jump to another group.
Sounds good.
What's the most popular place where a shark can live?
The most popular place where a shark can live. Popular. Okay, I don't know what will be the most popular, but what we know is that in Darwin and Wolf, which are two islands in the north of the Galapagos, we have found one of the highest biomass of sharks in the entire world. And many of the sharks are hammerheads. So the Galapagos is probably one of those places, very sharky place. And another one is La Isla del Coco, Costa Rica, where there is a crazy amount of tiger sharks.
Oh, tiger shark. Say thank you.
Mhm.
All right. Room 9, we'll try to pop back in for another one, but let's go to Mrs. Fisher's class. Let's get in here. Hey, everybody.
How big can hammerhead sharks get?
Ooh, that's a great question. More than 3 meters. That is for sure. Hammerheads get very big. Hammerheads, probably more than 3 meters. Is that your favorite? Your favorite shark? No. I love hammerheads. I have a necklace of hammerheads.
Oh, I was noticing that. That's great.
They're really beautiful. You know, if you go to Galapagos, you can get to dive with hammerheads.
Okay, good to know. I might try that.
Yes.
We had one more question, and it was for the America's Expedition group about their about some of the maps they showed us.
Are there any stronger currents than black?
Looking at the dark colors on your maps, are those the strongest, or does it ever get darker because they're stronger?
Actually, I do think that the wind and the current goes to white when it's very, very strong. So, so it's something you do have to look at. I was looking the other day down in Antarctica for some reason, and I know that the wind went to white.
Which was like 90 knots.
Yeah, so it would be a mistake to interpret that as no wind.
Yeah, it would be a mistake to interpret that. Exactly. So yeah, Yes.
Can you tell us just really quickly what knots like converts to? Like we're miles, our brains work in miles per hour. So
Yeah. So sorry, you're working in miles per hour?
What knots converts to?
Oh, what knots convert to? Well, a nautical mile is slightly longer than a statute mile. So a knot of current would be 1.2 knots of mile per hour. Am I right, Mike?
Yeah. Great question.
Yeah, good
Thank
question.
you.
Yeah, that's a good question.
Would love another one.
Yeah.
Yeah, I did a quick conversion. So 103 miles per hour, 90 knots would be 103 miles per hour.
Yeah.
That's pretty fast.
We've had some experience. It's hard to breathe when there's 100-mile-an-hour wind. You can't get enough air in your system unless you face the wind, and you blow up like a balloon.
All right. I'm gonna grab.
So just one little thing. Because someone mentioned in meters and miles. Yeah, I answered in meters, right? And I said 3. It's actually the average will be 4, and that is 4 meters. But to make any sense of that, that will mean for the kids that's known in feet will be 13 feet. Around 13 feet is the average size, so it's very big.
All right. Let's go. I'm going to grab one more from YouTube. Then I'll bring in a couple homeschool groups who are hanging out with us. So Elena here is 7 on YouTube and asking, how deep do you find the Dumbo octopuses?
Wow. Yeah. So this one in particular here was observed at 600 meters. This one here.
Wow.
Yeah.
Wow.
600 meters. So that multiplied by 3.
All right.
Wow.
Yeah.
Okay. Let's get a school group in here. We've got Cullen homeschooler hanging out with us today. How are we doing today, bud?
Good. Hi. My question is, for your job, Anna, how much time do you spend in the water versus on land?
Can you repeat that? Can you repeat that for me, please?
How much time do you spend in the water versus on land?
Oh, okay. Yeah. Remember I told you I was a bit jealous of my friend, the sea lion? Yeah, recently, because I'm working in my doctoral degree, I've been spending way too much time on land. Yeah, but in the past I used to work in the Galapagos and later in the Caribbean, and I used to spend in the water probably half time in the water and half time outside. But now, no, I'm spending now probably 60% of my time 70% of my time on land, which I'm looking forward to change. Thank you for the question. It's great.
Thank you.
All right. Do you have another one handy before we jump to another group?
How do you become a marine biologist?
Oh.
Wow, that's I love that question. I didn't know that I could be a marine biologist first. I just knew I love to be in the ocean. I want to protect the animals and the ocean in general, the marine animals in the ocean. But then when I was 12, I learned about Jacques Cousteau and all that. It's like, oh, okay, then it's a career path. So this is actually possible. I can actually make a life out of that. And so when I was 18, I went to the university to study for marine biology. And I studied 5 years on that. And then I did a master also for 2 years, and I work in the field. And that's how I became a marine biologist. Yeah. Thank you for that. But it's from the love for the ocean. Yeah.
That's a great question. We did a class too on blue pathways, and it talks about different ways you can maybe have a career working on the ocean, either from marine biology or even on boats or that kind of thing. So you can look that up on Joe's site, Pathways to the Blue Industry. And we have some different options that people could follow to maybe work for the ocean. Thank you for that question. It's a good one.
Thank you.
Yeah, excellent. Yeah. And if you have like a big question, you could actually work on that. Oh, I think he's gone. I'm so sad.
No, he
No,
can
they
hear
should-
you. So, yeah.
Okay, because if he has a question, like there is now very young people that propose to study a specific question. Like I know people that have gotten a National Geographic grant with 13 years old because they are concerned about plastic contamination in the ocean next to their home, and that's how you start. So yeah, as I said, there is many ways to do it, but if you have a feeling that you want to work for the ocean, a specific thing, do you want help? You want to help on? Please, there is ways to do it, even when you're very young.
Okay, let's grab another group. We've got Levi hanging out with us in North Carolina. There we go.
Hi, how are you all?
Hi again.
Hi again. Hi.
Hi, good to see you again.
Great to see you. Thank you for following us, you guys. We appreciate it.
How are you all doing today?
Wonderful. We're sitting here. We actually had some snow out here today. So we're doing wonderful, but we're hunkered in a bay, waiting out some low pressure windstorms that are rolling through. And just, again, looking at our navigation and timing and when we could maybe start venturing more north.
Well, we send you thoughts for my daughter said they have some beautiful views, Mama, but so do we. We should show them.
Yeah, thank you. It's gorgeous.
So
What do
I
you wanna
was
ask,
wondering, what are some human impacts that affect oxygen in the ocean?
Oh my God, I love that question. The biggest is the production of CO2. So because we are burning so much fuel, so much gas is used in big trucks, everyone has a car, companies use gas without thinking twice. That is a huge problem for the world because that CO2 goes to the atmosphere and warm up the world. And so the ocean, it absorbs like a sponge all that heat, and that has helped us a lot because without the ocean, this planet will already be, we could not live in this planet because the amount of heat that the ocean has already absorbed is tremendous. So now we have an ocean that is warm, and with this warming of the ocean, the oxygen is a gas that has to penetrate the ocean. It's harder. It's like when you have water with gas, or you have a Coca-Cola, and you warm it up, all the gas goes out. So when something gets warm and has gas, it loses this gas. So there is no more input from the atmosphere because the ocean is warming. So as much as it warms, as much oxygen is going to lose. And there are areas in our planet that already have extensive oxygen minimum zones. In the tropics, for example, because we don't have some movements of the water, like in the subtropics, you have a movement that is called Coriolis that makes the currents move horizontally. We don't have that because we're in the tropics. So the vertical movement of the water is essential. And now with this layering of the water, there is not much of that vertical exchange, and that reduces the oxygen there down in the deep ocean. Yes, excellent question.
Thank you. Thank you so much.
Thank you.
Do you have another question? Maybe
Yeah, but they
for
can come back to us.
Well, this might be our only round. Do you have another question
Well,
for
my
everybody?
other question was, what are some signs of resilience in the ocean?
And that's a question for everyone. You can chime in.
Resilience. As a scientist, we have to sometimes be very, very careful in the wording we use, because in order to really know, for example, for Galapagos, if these corals are resilient, we will have to come back and get more data so we know if actually they are now there. But what about, were they the same 5 years ago? We don't know. Are going to be there the same in 5 years from now? We don't know, because we only went so far a couple of times. So we can't tell for sure there's resilience. The only thing we can know about these coral reefs that we observe is that they're still there. So for that, there is hope that they're still there. But we know these factors like oxygen are essential for these animals. So if we really keep losing more oxygen, my personal belief is that will be hard to make sure these animals survive. Yeah.
for her.
And I'm going to have to say that I think what we're looking at too is some resilience, as we're seeing some very healthy kelp beds out here and some not so much. And I think maybe part of the resilience we're seeing are the humans. You know, they're out doing some incredible things and incredible work to help with our oceans. And I think that resilience in the humans, even though we have a big impact on the ocean, we also have some incredible people doing some amazing stuff to help our ocean. So I think that's part of what we're doing.
That's an excellent point. And one of the biggest things that humans can do to protect the ocean is actually get away from it, protect big areas, create real large marine protected areas. So there is this initiative that's called National Geographic Pristine Seas, and they go around the world and they identify pristine areas where the diversity is huge, and then they provide the science to help the local communities to have enough arguments so the governments can declare these areas protected. And they are not small, because as bigger as a protected area is, as better. So that's also one of the reasons why the Galapagos is still in such a good state. There is impact mostly in shallow waters, but in the deep sea, there is no such a thing as bottom trawling or mining or oil extraction. And so that's why we have to really be careful. Sometimes, like, people talk very loose about mining the deep sea without we even knowing what is there down yet and what is the importance. So it's very important to protect these areas.
99% of the living space.
Yes.
Right?
Yeah, especially. Yes, huge. It's true. We don't know the stance of our impacts if we keep doing these things, and it can be dangerous not only for the animals there, but for our own life because of the role of the ocean.
Okay.
Thank you so much.
Thank you.
That was awesome.
Thank you.
Great question. Thank you.
Thank you.
So
And we'll
much.
be back for more of your programs. So we'll see you soon.
Thank you.
All right. Let's say our group in Maine is still with us. So I bet there's so many there. They probably have another question.
Hi.
How long have you been working, like, for this?
I am not that young, so these people think I'm very young, but I've actually been working on this for already 17 years.
17? How?
Yeah.
Why?
Yeah.
Well,
You know something,
Those
you
people are
guys?
young.
Just you kids listening to these programs and learning, you're already working for the ocean and you're already ocean stewards. So you're on the right path, and we thank you very much for your interest in the ocean. Nice job, everybody.
You say thank you.
You guys think 17 years is a lot. I think this guy has also been working for the ocean for some time as well.
Still trying.
Yeah, never.
Yeah,
never too late.
don't give up. You know, one of the things that I'm hearing is sort of the theme of this is that it's one ocean out there. It connects us all, and we have to take care of every part of it.
Yeah.
And you're a big reason. You can learn about it, and you can tell others about it, and work on it, and that's what it's going to take. Everybody can do one little thing.
And the really neat thing, you guys, we met kids way down here in southern Chile that are looking after the ocean and very caring about the ocean. And we're hoping to connect all of you together. And that's our big goal, is having all these classrooms all around North and South America looking at this beautiful one island and looking after our beautiful ocean together. And we're finding that as we go, everybody's very interested. Yes.
Thank you so much.
Okay, well, I think we're at about that time. I'm going to see if I can turn my camera on here one more time. I'm going to grab in our classrooms from backstage. We still have some folks hanging out with us. Anna, thank you so much for being with us today and sharing your work around the Americas team. Thank you so much. Thanks so much, everybody, but we're going to have to sign off for today. It was good to see everyone.
Great
Thank you
class.
so
Thank you
much.
very much.
Very good.
All right,
Thank you for
everyone. Have a
coming.
great rest of the week.
See you later.
Thank you so
Bye.
much, everyone. for
Have a
being